All right, so Tuesday and Wednesday, we focus just on when is my function positive, when is my function negative. Today we're going to take a look at a couple of things. They're not as, at least in my opinion, not as difficult concepts to grasp as the whole positive and negative thing. But we'll see. Maybe it is. So the first idea is a line of symmetry. What does it mean for something to be symmetrical? Yeah, Tristan. Same on both sides, right? So a line of symmetry is a line that splits a function evenly, also known as a mirror line. All right? This is super easy, okay? Take a look at these three graphs. And for 30 seconds, talk in your groups. Which of these functions have a line of symmetry? Don't write anything down yet, because I don't want you to have to erase in case you're wrong. Just have a conversation. Which one of these do you think has a line of symmetry? Which one of them don't? Go ahead, take 30 seconds right now. Go.
The first one obviously because if you split it down to negative, the second one and the third or by the way, so the alligator thingies were called angle brackets. I searched them up.
They're called what?
Angle brackets. Angle bracket to the left, the angle bracket to the right. Yeah, that's what they call it.
I think they're referring to when you're talking about an angle, like angle 6. They might be called something different when we're talking about an inequality. I don't know though. Chevron's the easiest to say, so I'm going to say that. He said it's called a chevron.
It's either, it says angle brackets or inequality.
Perfect. Still too long to say. I mean, it's sort of an alligator mouth, I guess. All right, let's come back together. Christian. Sure. All right, let's see what you guys came up with. Okay? Let's take a look at this first graph right here. What do we call this shape again? Do you remember?
Parabola.
Parabola, right? So, if you think this function has a line of symmetry, you're going to give me a thumbs up. If you think it doesn't, you're going to give me a thumbs down. What do you think for number one? Thumbs up, thumbs down. Ooh. Everyone has their thumbs down. And I think I know why. So you're all wrong for that first one. Let's try the second one. Give me a thumbs up if you think it does have a line of symmetry. Give me a thumbs down if you think it does not have a line of symmetry. Okay, this one's like 75 say no, 25 say yes. Okay, this one is a no. What about this last one? Give me a thumbs up, line of symmetry, thumbs down, not a line of symmetry. This one is pretty much 50-50 yes and no. This one is a no. Okay?
The first one was a yes, right?
Yes.
I got it right!
Okay. All right, let's relax. Relax.
If you split it down,
Take a look. I could whip up an Alex assignment. Do you wanna do that, or do you wanna listen? Okay. So take a look right here. If I drew a line through x equals 3, is my function perfectly symmetrical on both sides? Yes. So yes, this does have a line of symmetry. My line of symmetry, the equation would be x equals 3. It doesn't have to be symmetrical on the y-axis. It just has to be symmetrical on some type of line. And I think that's why we all had our thumbs down. Because you thought, oh, this thing is shifted over to the right. That wouldn't be symmetrical. Well, if you're talking about in reference to the y-axis, yes. But in reference to the line x equals 3, Yeah, it is 100% symmetrical. Now for this second one, there's not a single line we could draw here, right, that makes this symmetrical. So that would be no. If I drew a line even like kind of through the middle, right? Right? It's not symmetrical. If it was like that would be symmetrical.
That's what they meant by mirror.
Yeah, like a mirror, right? If I look in the mirror, I'm not upside down, right? It's backwards, but it's not upside down.
That's what they meant by mirror. I forgot.
Yep. Okay. Now this one is tricky, right? This one we have like a 50-50 split, right?
This one's not a mirror either because the only way it would be a mirror if it goes up the other way. Yeah.
Exactly. And if you draw this line right here, you may think, oh, it's mirrored, but it's mirrored and flipped. We don't want that, right? Again, if it looked like that, that would have a line of symmetry. But because it looks like that, that is not a line of symmetry. Tyler?
It's also not, even if it was like that and it wasn't flipped, it still wouldn't be clean.
I actually already.
Say that one more time.
Oh, never mind.
Oh,
I actually already learned about this about mirror lines.
Good.
Earlier this year.
that's good.
I learned about it in my college.
Even if I wanted to take, like, what if the x-axis is a line of symmetry? Nope, it's still the same thing. Right? They're split in different ways. So in terms of symmetry, that's like the extent of what we need to talk about. Are there any questions I can answer about that? Now that we went over it, does it make a little bit of sense?
Yes.
Now that you guys know what to look for? Okay, it makes sense to Abigail and Tia and Colby. That's it. That's the only people it makes sense to. Oh, it makes sense to Raven and Melanie and Justin and Liana and Judah and Chelsea. Okay, good. Let's kick it up a notch. This is what, Alex, you were talking about earlier, okay?
Yeah. Oh, I was.
So if you open up a book, where are you going to start reading? On the left side or the right side? Left side.
I've been reading too much.
So go ahead and highlight from left to right. We are reading these functions from left to right. Okay? With yesterday's lesson, we were more concerned about up and down, which one's on the top, which one's on the bottom. Now we're reading from left to right. Okay? And we're going to read this. Off to the side, you can write, like a roller coaster. Give me a thumbs up if you've ever been on a roller coaster before.
I think so.
Me.
You think so?
You think so?
Okay.
I think I've been on one.
Sounds like something you should know, but that's okay.
I think I was on a roller coaster when I was too young.
No, because I've never been like that. But I started praying, bro.
I don't think they let 5-year-olds on roller coasters.
So let's take a look. A roller coaster, here's your little car, right? Okay, let's say it's going up, 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 and then it goes down, and then it goes back up, and it goes back down. All right? Everybody, in their mind, they can see this roller coaster, yeah? Okay. So what's happening in this section right here?
You're ascending.
You're ascending. You're going up.
It's also
Your height is increasing. Yes?
Yes.
Increasing.
Increase in.
All right?
Yeah. Alright.
What happens right here?
Stop.
You stop. Right? Because what are you changing now in this section?
You're descending.
Your direction. You're going down. You're
Faster
descending.
than ascending. Because of gravity. That's why.
Right? You're decreasing your height.
Yeah.
What happens right here?
You stop because of the friction.
You stop because of the friction. Well, the roller coaster's not going to stop in the middle of the ride.
It's just gonna slow down.
What do you change though?
Speed.
Speed, yeah. Height, yeah. Judah? Oh. You're changing, so you went down. What's going to happen next?
You ascend again.
You're going back up, so you're changing what? Direction. Right? What happens right here?
You
You
pause.
pause.
Okay, you're not, it's not a pause, right? But you're, again, you're changing what? Directions again. Now you're going down.
Descending faster.
Okay? Give me a thumbs up if you're following that mental image there. Even if you've never been on a roller coaster, hopefully you've seen one before, right?
There's always.
We went from the left to the right. That's exactly how we're reading these functions. If I'm looking at this function right here, right? I'm going to start all the way here on the left. All right? With my non-yellow highlighter, whatever color you have, your non-yellow highlighter. We're going to follow this function all the way down until we hit point B. Right? If this is my little roller coaster car, what's happening on the roller coaster on this pink section? You're descending. You're going down. Your height is decreasing. All right? And then you hit this little point down here, point B. And what changes at point B? Your direction. Your direction. What's happening in that yellow section of the function now? You're increasing. You're ascending. You're going up. Right? Here you are. You're going down. Hit point B, and now you're going up. Everyone got that highlighting done?
Yeah.
So this is where we have to be careful, right? This pink section of my function shows a decrease. But what our brain tells us is, hey, this arrow is pointing up. That must be an increase. But that's not how it is, because we're reading from left to right. All right? If I start on the left and I go to the right, I'm decreasing. I hit this point, and then I start increasing. Okay? So what interval on the graph am I decreasing? Well, I'm decreasing when x is less than 0. This whole left side of my graph are my x values that are less than 0, my negatives. So that's the interval in which I'm decreasing. What interval am I increasing? When x is greater than 0. This whole right side of my function. We're not paying attention to where it falls on the x-axis. We're looking at direction. So this is where it gets confusing, right? Because we just talked about positive intervals and negative intervals. Now we're talking about decreasing intervals and increasing intervals. Similar, but very different. So I want to make sure we understand the difference there. Does that roller coaster analogy help, though?
Yes.
It helped me when I was learning it last night. Just kidding. When I was a student, that's how I used to think of it, like a roller coaster. I don't know. I like roller coasters, so that's how. Anyway, okay, the last point. So we talked about line of symmetry. We talked about increasing, decreasing. Now we're going to talk about this word extrema. Everybody say extrema. Extrema. What's the root word there of extrema?
Extreme.
Extreme. Right? Extreme. Which also plays into our roller coaster analogy. So what is an extrema? An extrema is a point on a function graph that are relatively high or relatively low when compared to the points around it. More simply put, it's a change of direction, right? So on this function graph here, what point did we change direction?
B point.
We changed directions right here at point B. Change of direction. So we know that point B is my extrema point. Now there's two types of extrema. You guys okay? Anthony, Kai? Okay. Extrema points can either be a relative minimum right? Or a relative maximum, right? What is minimum?
The
Least, small, lower, maximum, larger, higher, taller,
yes.
right? So if I'm looking at this curve, right, what's the lowest point of my curve?
B.
Point B. So do you think that would be a relative minimum or a relative maximum? Minimum, because it's low down. Point B is an extrema point. It's a relative minimum because there are no other points on my function nearby that are lower than this point. So an extrema point is anywhere where we change directions. If we look back at this roller coaster, right? How many times did we change directions on this roller coaster?
Three times.
4.
3. There's
I mean, if we don't count this first one, we changed directions here, here, and here,
So 3 dots.
right? So there's 3 dots. This dot up here, this dot down there, and this dot down there. We're not going to worry about this guy over here, okay? So if I'm looking at these 3 dots, they are all either a minimum or a maximum. How many minimums do I have on this graph? Just one, right? If I said this was A, B, and C, where's my relative minimum? Which point?
B.
Point B. How do I know it's a minimum and not a maximum?
Because it's the lowest point in the graph.
Because it's low down. Relative minimum. What would A and C be then? Maximum. These are relative maximums. Right?
Yeah.
Now, clearly point A is higher up than point C, but when I compare point A to this point, and that point, and that point, and that point, the points around it, clearly point A is the highest, right? So it's not the highest point, but it's relatively high up. That's why it's called the relative maximum, right? Same thing here. When I compare point C to these points around it, it's clearly the highest of those points, making it the relative max. Take a look at this function. Are there any relative maximum here?
No. Yes. Maybe.
No? Yes? Talk about it with your group. What do you think? Real quick, 30 seconds. Are there any relative maximums? If there are, what are they?
I think it's not because it goes further up. So.
Yeah, it's probably through none. It goes further up. So the more you get.
No comment. All right, what do you guys think? Are there any relative maximum on this graph? Yes or no?
No.
I hear some yeses, I hear some no's. Who wants to defend their position on yes?
Me. Oh, no.
Who says yes? Real quick. It's okay to be wrong if you're wrong. I'm not saying yes is wrong. Joanne, why do you say yes? What would your relative maximums be? A and C. Okay. Anyone else think that A and C were relative maximums? You don't have to admit it. I know you did. Good. Yeah, a couple of us do. Why? What makes you say those are relative maximums, Joanne? Because they're high points, right? Compared to point B, oh yeah, they're definitely much higher than point B. So I love that thinking. That's absolutely right. Who wants to make an argument that there are no relative maximums? Anthony.
It's like I learned this in history. Like when the economy goes up, all the people like.
No, yeah. You're on the right track.
So look, let's say like A and C have like $100.
Okay.
And they make a lot of money. And let's say a lot of like D, G, F, G also make like $100.
Okay.
So it's gonna look like A and C is normal, and then make D like make B look really low.
I see what you're saying.
I don't think you do.
I don't know if I do either. But I love the connection. That's great. Andrew?
I don't think there's any relative maximums because it goes higher and higher to infinity.
Good. Okay, Tyler, what were you gonna say?
Same thing, because like at point C and A, there's like options to go higher.
That's right. So, good. I like that you said that. If I were to make, let's take a little look here. If I were to make an additional point right here, right? That's pretty close to point C. Is it higher up than point C?
Yeah.
Yes, it is. So C can't be a max, right? There's no point along this function lower than B in that section, right? So we know it's a minimum. But there's plenty of points directly above C and directly above A. What else did we say about extrema? We said that extrema are a, didn't I write it down? Oh yeah. They're a change of what? Direction. Do I change directions at point A? No, I keep going down. Do I change directions at point C? No, I keep going up. Do I change directions at point B? Yes, that's where we start, or we change from going down to going back up. Anthony,
What if it doesn't move?
say that one more time.
What if it doesn't move?
What if what doesn't move?
It's like, what if A goes down and it has like, and B has like a 5-second pause? What would that be?
I'm trying to understand what you're. So this isn't a moving thing.
Like, remember when you said on a roller coaster, it has like a little pause before it decreases?
So you're talking about like if the roller coaster was going up, 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 and it starts right here?
Yeah. What if it has like a really long pause?
I mean, that's fine.
It's not fun. It scares you. It scares me.
No, I said it's fine, not fun. It's definitely not fun, but
It has a long pause and the.
it's still a maximum if that's what you're asking. Yeah,
If the roller coaster's at a long pause, there's always no malfunction.
probably.
No, it's they were like.
So extrema are where we change directions, okay? That's the important thing to know. Hold on, guys. Even if you're given points like A and C, and you think, oh, they gave me a point, that must be one of my things. Not always, okay? I'm letting you know right now. It's not always going to be a minimum or a maximum, okay? How are we feeling about that? Quick show of thumbs. We feeling okay? Is this easier than the positive, negative stuff we've been talking about? Yeah? Okay. Good. Let's get the second piece then. See if you can work through it on your own. This will be our homework replacement because we can do it in 10 minutes. Oh, you want this and homework?
No. Be quiet, guys. Be quiet.
On the agenda, I said no homework. I don't get it. Bro, I'm bipolar. I can't.
I think that's bipolar.
I can't.
You smiling. They would have put you in support.
Oh shit. What do you mean only got used on Mondays?
No. How would you?
That's what I'm saying. What do you mean only got? Bro, Alex, I was always telling Alex like fucking that because I was actually so dumb. Did not understand a single thing about that. Oh my god, I got Alex, you get it? Is it a minus dimension? No, I don't think it is. No, right? Because it's split. Right?
Wait. If we split it through the middle, that's not minus. Yeah, that is not. It's not.
What do you mean, huh? But what do you want?